Hey folks, welcome back to another video. Today we're looking at question 19, remove nth node from the list. The way we'll be approaching this problem is by using two pointers, the fast pointer and the slow pointer. And what we're going to do with the fast pointer is that before we do anything at all, we will move that to n steps forward. And then once it is n steps ahead from the start, we move both the slow and the fast pointer together. And what we're doing with this is that we have established a space of n nodes between the slow and the fast pointer. So when the fast pointer reaches the end of the node, you know that the slow pointer is pointing towards the node that we want to eliminate. So therefore, we will use this methodology to eliminate the node, the nth node. Awesome. So let's jump right in. So with any list node linked list problem, so what we need to do is we need to establish a dummy node. And the reason why we do this is because even if we move the head, we don't lose a track of it. And then dummy would become dummy. Dummy.next would be pointed to head. And then what do we have? And then we need two nodes, slow, which would also point to dummy. And then we have fast node, which also points to dummy. Once we have initialized that, what we need to do is we need to move the fast node by n nodes, right? So we establish I to be equal to 0, and then we have while I is less than n, and while fast is not equal to null, what you need to do is we need to keep, let me just, okay, yeah, that makes sense. All right, so we increment I, and we do fast is equal to fast.next. So what is this entire piece of code doing? What it's doing is that it's just moving the fast node to the end node from the beginning. Once we have that, we need another while loop, while fast.next is not equal to null. What we need to do is that we need to move the fast node and the slow node together. So what are we doing? What we're doing is that we are moving all the fast node and the slow node together. However, the gap between the fast node and the slow node will always be n nodes. So as soon as the last node is reached, we know that we are at the nth minus one node with slow, right? So once we have that, you know that slow, the next node is pointing towards the nth node that we actually want to eliminate. So how do we eliminate that? So slow.next would be equal to slow.next.next. So what are we saying? It's like, we are saying with this line is, hey, you know what? The next node, just leave it as is, forget that, and just point to the node after. So this is what you're doing with this line. And in the end, you're returning dummy.next. So what is dummy.next pointing to? To head. So you're eliminating the nth node, and you're returning the head. Awesome. So let's compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the solution. The time complexity of the solution is O of n, since we actually have to move through the entire linked list. The space complexity of the solution is O of 1, since we're not using any additional space to store any data. So this is the solution. If you have any questions about the problem, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I really would appreciate that. It motivates me to make more videos. Thank you.